Chapter 16, Threads in AutoCAD. Some of the common websites to order hardware, bolts, nuts, washers, and other types of hardware. You can go to mcmaster.com or carlane.com. You can also download drawings for bolts, nuts, etc. And they also provide 3D models of their hardware. Okay, so here we have two plates. The one at the bottom has a tapped hole, so it's threaded. So the bolt will engage with this tapped hole. And this plate is going to be sandwiched in between the two, between the head of the bolt and this lower plate. So we're basically clamping down this plate onto this one. And the hole here is a clearance hole. It's just a plain hole, and the hole will be larger than the bolt. This hole is not meant for accuracy. It's just meant to provide clearance for the bolt, and the head of the bolt is going to do all the clamping down of that plate onto the lower plate. Okay, so what size diameter should we provide for this clearance hole? Well, it depends on the diameter of the bolt. Let's take a look at this chart for inches, inch clearances. So if we have a 1-inch diameter bolt, so 1-inch diameter bolt, what size should the clearance hole be? So it's just the diameter, which is 1 inch plus 3/32. That should be the diameter of the clearance hole. Okay, if you're dealing with something under an inch in diameter, so let's say you have a 1/2 inch diameter up to 7/8, then you're going to add to that diameter 1/16 of an inch, which is 0.0625. Okay, so let's say we're dealing with the 1/2 inch diameter, which is 0.50 inches, 0.50. So the bolt is 1/2 inch diameter. So for the clearance hole, you're going to add 1/16. So it's just 0.50 plus 0.0625, and that'll give us 0.5625 diameter for the clearance hole. Okay, and if it's below 1/2 inch diameter, then you add 1/32. Okay, so 1/32 is about 0.03. It's actually 0.03125, but it's 0.03. So add 0.03 to whatever diameter size you use. Typically, the range you're going to be working with is this range. You hardly ever go over an inch. It's very rare where you go over a bolt the size of 1 inch. Bolts are very strong. They're treated, so it can handle a lot of forces. Typically about 5 times the strength of steel after it gets treated. So typically you'll be in this range as far as bolt sizes. And you want to add a clearance hole just by simply adding 1/32, which is 0.03. Okay, so if you're dealing with a quarter or 0.25 diameter, 0.25 diameter bolt at 0.03, and so you'll have a clearance hole of 0.28. And for metric, we're going to use these for our clearances. Okay, so these are the charts that you're going to follow. Typically, I'll go with 0.03 and maybe 0.06 for my clearances, depending on the size of the bolt. Okay, let's talk about thread engagement. So one question that I always get is how much engagement should you get between the bolt and the tapped hole? Okay, so that depends on the diameter of the bolt. Most of the times you're going to be dealing with either aluminum or steel when it comes to tapped holes, threaded holes. So if you're dealing with steel, how much engagement do you want? So the engagement, we'll call it Y, equals 1 times the diameter of the bolt. That's the minimum engagement we want. So for example, if the diameter of the bolt is a 1-inch maximum diameter for the bolt, then you want at least 1-inch engagement if this is steel. So minimum 1 inch, so you can go higher than 1 inch. For aluminum, we're going to use Y equals 1.5 times the diameter, the major diameter of the bolt. That's the minimum amount of engagement we want between the bolt and the tapped hole. Okay, so if this is 1 inch, multiply times 1.5, and we want at least 1.5 inches of engagement between the threads of the bolt and the tapped hole. So these are minimums. We've talked about counterbore holes in the past. That's where you drill a small diameter hole into a block, and then you come in and drill a larger diameter hole. That's referred to as a counterbore hole. And 99% of the time it's to accommodate a bolt and to hide the head of the bolt. Okay, so in some cases, like in the previous slide, if you don't want the head sticking out because maybe something may be on top, sliding back and forth, or you don't want it to get in the way of some other operation, then one thing you can do is hide the head of the bolt by drilling a counterbore hole. Okay, so what size hole do we use for the head? So obviously it's a clearance hole. The hole will always be larger than the head. And again, you're going to be able to stick a credit card or something thicker between the head of the bolt and the hole. Okay, so what size hole do we drill for the head? So here's the formula. C1 equals the diameter of the head of the bolt. So whatever diameter this is, let's say 1 inch diameter, just to keep it simple, and you add 1/8 to it. Okay, so the size of the hole for the counterbore will be 1 inch plus 1/8, which equals 1.125 inches. If you go a little bit larger, it's okay. It's just a clearance hole. It's to provide clearance for the head. Now, as far as how deep, we'll call it CH, how deep is this counterbore hole, the depth? Well, H is the height of the head. Okay, so the depth of the hole, the counterbore hole, will be the height of the head plus 1/16. Okay, so just to keep it simple, if this is 1 inch for the size of the, or the height of the head, 1 inch, then the hole you're going to make it 1 and 1/16. Okay, so whatever the height of the head plus 1/16, and that is 1.0625. And you just want the head to be just below the top of the plate. You don't want it to be flush. You want it slightly below. Unless the plate is too thin, then it's okay to leave the head sticking out. But typically, when we create a counterbore hole, it's to hide the head, and we want it below the top surface. We don't want it flush. We don't want the head sticking out. So we just want to go slightly below, and 1/16 is good enough. If you want to go deeper, that's okay. What will we learn in Chapter 16? How to represent and dimension threads and draw nuts and bolts using the simplified thread symbol. The simplified representation of a thread is very simple and easy to draw. It consists of nothing more than straight, visible, and hidden lines. Okay, so this is the simplified version. This is for the threads end, or you can say where they start. This part here is straight, simple shaft, no threads. The threads start here, and it continues on all the way to the end. And then we have chamfer. We have a chamfer going around. That's so it's easy to line up the bolt with the tapped hole. Okay, so this here is the major diameter, and the dashed line represents the minor diameter. And once again, we have a chamfer. So this is the chamfer line. Now, typically, even though this is the simplified version, there's even a simpler, more simplified version. It's simply by leaving out the dashed lines. So it's okay if you leave out the dashed lines for the minor diameter. And we can just call out the major diameter with the leader and represent and show a line to represent what the threads start or where they end. So this is the threaded area. And you can just leave this without any note. It'll be assumed that this is a straight shaft, smooth shaft with no threads. And for a tapped hole, so here we have a block with a hole that's tapped, so it has threads. The dashed lines represent the major diameter, and the solid circle represents the minor diameter. Okay, so when we do a side view of this hole, this tapped hole, the simplified version is to do a double dash line to represent the major and minor diameter of the threads of the tapped hole. Now typically on a drawing you'll see instead of double dash lines just one dash line. The reason is because if it's a small hole, then these double dash lines are going to be too tight together. So it's just better just to draw one dash line instead of the double dash lines. Okay, and this represents the depth, how much engagement you will get, 2 inches. And then you go beyond, and this is where it starts tapering. And then we have this V shape due to the drill. So the tap that goes in here, or first you'll drill a small diameter hole, and then you come in and tap it. So this represents the end of the drill, which has a conic shape. It's just easier to scoop material by having a conic end here on the drill. Now AutoCAD has a limited selection of predefined nuts and bolts available in the machine tool palette. So instead of having to draw bolts and nuts, you can actually bring them in from the catalog built into AutoCAD. Okay, so if you go to the View tab in AutoCAD, go to the View tab, go to Tool Palettes, give it a few seconds, and this window will pop up. And there's already some hardware and also some common symbols that are used in AutoCAD. Something as simple as bolts, nuts, and also electrical symbols. There's also a lot of architectural symbols like windows and doors, toilet, sinks, etc. So these are in your library of tool palettes, and I will show you how to access these tools in a later lecture. So we're going to call out this tapped hole using the metric system. So in this case, we're going to use a diameter of 16 millimeters, coarse thread. So how do we call that out? We call it out with the letter M, letting us know we're using the metric system. And we're using 16 millimeters for our diameter by the pitch. This is the distance between the threads. So it's 2 millimeter distance between the threads. All right, for your assignment, even though this is chapter 16, threads using AutoCAD, we're going to do a problem from the back of chapter 18. So we'll be going over chapter 18-1 for your assignment. Next slide. So problem 18-1, draw and dimension the bracket using proper dimensioning techniques. This bracket is part of the pulley assembly given in the assembly chapter problem section. So this is the assembly. As you can see, it's made up of multiple parts. We have the pulley being held in place by a shaft. So we have a solid cylinder. And to stop the shaft from sliding out, we have a set screw. Okay, so a set screw is just a screw without a head. And the reason for it is so that you don't over tighten, and in this case, damage the shaft. So for our assignment, we're going to model in AutoCAD the bracket or the fork. Okay, we're not going to draw the entire assembly. We will cover assemblies in the next chapter. Okay, so our assignment is to just create the drawing for the bracket or the fork. So you're going to create a front view, top view, side view, and you are going to add dimensions. And here's our thread callout. So this assignment is in millimeters. Units are in millimeters. And we have a hole with threads, a tapped hole. And the size of the thread is M8 by 125. So the M is for a metric system. And we are using millimeters. So the diameter, the major diameter of the thread is 8 millimeters by 125. So the 1.25 tells us the pitch. That's the distance between the threads, which is 1.25 millimeters. All right, so you're going to watch the next video if you need help. Step by step, it'll show you how to create the 3 views, the dimensioning, the thread callout, and also we'll have tolerances, and title block and border will be optional. Next slide. End of chapter 16, Threads in AutoCAD.